Now, let's look at what we can do further to analyze word frequencies. By the end of this video, you should be able to count how many times an item appears in a list, plot word frequency in logarithmic axis, and plot word counts histograms. When we switch to our notebook, we will see that a quick check of the amount of words in our movie review database shows 1.6 million words, which can then be reduced to 710,000 via removal of useless words, as we called it. This is still a lot of words. How can we find out the frequency of each word? That is, how many times each word appears in this corpus. We will use the counter object from the collection package in Python for this purpose. Counter works very similar to the unique command in Unix we discussed before. We can provide it with a list of words, and it returns an object via which we can find out the repetition of each word. You would already guess that movie is a very frequent word in a movie database, and indeed, it occurs 5,771 times in this corpus. Once we have frequency in a counter for each word, we will see how we can plot the distribution of words using Matplotlib. This graph is copied from our notebook where we sorted the word counts and plotted their values on logarithmic axis to check the shape of the distribution. This visualization is particularly useful if you're comparing two or more datasets. A flatter distribution indicates a large vocabulary, while a peak distribution indicates a restricted vocabulary, often due to a focused topic or specialized language. We will also create histograms of the words for visualization of the frequencies. Let's now switch to our notebook to see what we just reviewed in action. We are now starting to count frequencies of words in the movie reviews corpus. Let's go to our notebook and first check the number of words quickly using the len function. As we mentioned before, we can get all the words in the movie reviews and assign it to all words. And we'll use the len function around those all words and print it in the millions format. We reviewed some of these in our very early videos. Hope you still remember. So what we are doing here is we are turning this number into millions format. So we have about 1.6 million words. It's a lot of words. But this number includes the useless words we listed before. Let's filter those words out here using a for loop and call this result or the resulting list filtered words. So what we'll do, we'll assign to filter words the output of this word loop, the for loop. It says word for word in movie reviews words. So if for each word in the movie reviews, only do this if word is not in useless words. So we can execute this. If you'd like to see the type of this filtered words, let's execute this again. It takes a little while because it's checking constantly if the word is in a list. We see that filtered words is indeed a list. And we'll get the number of words in this list. It's now down to about 710,000, so 0.71 million. So it's about half. We were able to reduce the amount of words to about half. Next, let's create a counter object using these filtered words. What we'll do is we'll start by importing counter from collections. And we'll give counter this filtered words. That's like 710,000 words. And we'll turn that into a counter object. This counter class that we are initializing here will create a word counter object. So I'm running this. Once we have this word counter object, it was successfully ran. It was fast, as you saw. We can use any function the counter class provides us, or the properties of this class. Most common function of the counter object lets us see the most frequency words in our movie database. Let's actually execute that, and in the next one I'll print this most common words, the top 10, as you've seen here. As we see here, most common words are the ones with the highest frequency in our movie database. As expected, are film, one, and movie. Let's plot now this word counter. We need to sort this list before we can plot it, actually. We will use Matplotlib, as you've seen before. Matplotlib, you're familiar with it. We'll use it to generate a logarithmic plot of the list. So we had sorted word counter and the values in it, and we assigned that to a list called sorted word counts. We'll give those sorted word counts to the log function to create that logarithmic plot, and we'll name our X label word rank and Y label frequency. So if we do this, we'll have that graph we overviewed in our slides before. It's a logarithmic plot, and as we describe here, this flatter distribution indicates a large vocabulary like we have. We can also plot the histogram of sorted word counts, right, which displays how many words have a count in a specific range. Not per word, but the words are binned to be together if they have a similar count. So since we have many words with low frequencies in our histogram or in our corpus, we'll see that the histogram peaks on these low counts. Right? Close to 0, we have a huge spike of words, and it sort of trickles down to be less and less, in the order of 5,000s. Displaying this at log scale, in this case, would give us a better plot to communicate this information. So what we'll do is, instead of histogram sorted value counts, we'll say log through here, the same 50 bins, and we'll have a better, more informative graph. And you will learn more about it as you go through probability and other classes in this specialization. Great. We are almost at the end of our notebook. As usual, we save the best for last. That is to use the exploratory analysis we just went through in a classification model. Let's go through this in the next set of videos to see how we can achieve it.